Today we will be discussing about the viscosity. So today's topic is viscosity. Now, in order to understand viscosity, I already said viscosity is meant for fluid. It means anything that flows. So it can be liquid or it can be a gas. But generally we have the concept of viscosity for the liquid. Okay. So what exactly is the condition? It is the property of a liquid. Viscosity is the property of a liquid by virtue of which an opposing force, that is what we call, it may be the internal friction coming into play. So viscosity, it is the property by virtue of which an opposing force comes into play between the layers of the liquid whenever there is a relative motion between the layers. Now what exactly we mean? Suppose if we use, for example, you are standing in a river, and you might have noticed that the flow of the river of water of the river is more at the upper surface as compared to the bottom. So generally, suppose this is the bottom part of the river, and if we have considered this as one of the layer of the liquid, and if we have considered another layer of the liquid, okay, so in this case we have considered there is a flow of liquid. The liquid is flowing in this way, flow of liquid, flow of river. So what you really find that if I consider two different layers, they are into the relative motion. So in between the two, there is an opposing force, and this tries to restrict the motion of the other. So here also if I say, then there is a restriction on the motion of this layer. So ultimately you will find that suppose if this has got the velocity v, then it will have more velocity just because it is not attached to the solid surface. So it's velocity v plus delta v, okay, and the distance between the two is delta x. So delta x is the distance between the two layers, v is the velocity of the this layer, and v plus delta v is the velocity of the upper layer. So what exactly is velocity? This force, the viscous force, that is this force is acting in the opposite direction. So this F is your viscous force. F is the viscous force, and this F viscous force is directly proportional to the velocity gradient. Velocity gradient is delta V by delta X, and it is directly proportional to area of the layer. And delta V by delta X, if the limit delta x is tending towards 0, so we can find that this delta V by delta X for the limit delta x tending towards 0, this becomes dv by dx, and this what we call is velocity gradient. We call this as velocity gradient, that is the change of velocity with respect to distance. So if we combine these two relation, f is proportional to a dv by dx. If we combine these two relation, then f is equals to minus eta a dv by dx. Now this eta is known as coefficient of viscosity. So this eta is known as coefficient of viscosity, and since it is the coefficient of viscosity, the negative sign shows that the direction of the this force is just opposite to the flow of the liquid. Okay, and we have got the SI unit is SI unit of eta. SI unit of eta is Newton second per meter square or decapoise, whereas CGS unit is poise, and we have 1 decapoise is equals to 10 poise. So this is what relation we have derived for viscosity. Viscosity is the phenomena in which there is a opposing force due to the motion of the relative motion between the layers of the liquid. So we have got F as the viscous force. So F is proportional to dv delta v. We have got delta v by delta x, limit delta x tending towards 0, dv by dx. So we have got F as proportional to a dv by dx. If we remove the proportionality sign, it is minus eta A dv by dx. Eta is the coefficient of viscosity, A is the area of the layer. dv by dx is becoming what? It is the velocity gradient. So SI unit of eta is Newton second per meter square or decapoise, and CGS unit is poise. So 1 decapoise is equals to 10 poise. So this is the relation. And if we go for the dimensional formula, then this formula comes as ml minus 1 t to the power minus 2. Okay, so this is the t to the power minus 1. So this is the dimensional formula for the coefficient of viscosity. Now this viscosity is, if you get to see how it depends upon the temperature, then we have the viscosity of liquid, it decreases with the increase in temperature. Dependence, if I have the dependence, then eta is proportional to 1 by root over t. So this eta decreases as the temperature increases and vice versa relation. Okay, now what are the some applications of viscosity in our daily life? Now, viscosity of liquid varies with temperature, so the proper choice of lubricant and used in machines is made depending upon the season, hot or cold. Liquids of high viscosity are used in shock absorbers and buffers of trains. We have got, it finds an important use in the circulation of blood through arteries and veins of human body. The knowledge of viscosity of organic liquid is used in determining the molecular weight and the shape of the organic molecules. So this is, now it looks as if the viscosity is and it's just like a solid friction, but there is a lots of difference between viscosity and friction. Why? Because the friction does not friction depends upon the area, but friction does not depend upon the area, but viscosity depends upon the area. You can see in the equation A is given. Further, viscosity does not depend upon the normal reaction, but if you might have seen the equation for the friction, it depends upon the normal reactions. So these are the basic differences for the viscosity and the friction. Okay, I hope you must have understood this, the concept of viscosity. So viscosity, the main have already written what it is, with units and all. Thank you for watching.